Alright, welcome to Vibrations and Acoustics. In this problem we have a couple of basic conditions for a vibratory system of some kind. We don't really know what it is, but we know it has a vibration of 15 cycles per second and a max acceleration of 0.5 g. Alright, so in order to work with this, we want to make sure everything's in kind of the same units and we can get as much information gleaned from all of this as we can. So we know omega is equal to 15 cycles per second, or hertz, which is also cycles per second basically. But we want to do a conversion on this to get it into radians per second, because in vibrations you're usually working in radians. So what we're going to do is just multiply this by 2 pi, and that'll turn it from cycles per second into radians per second, and it'll equal 94.248 radians per second. Alrighty. So now we also have this vibration. Vibration can be denoted as acceleration can be denoted as x double dot. We want to get the max acceleration because we know that's what it is. It's going to equal 0.5 g, which is equal to 0.5 times 9.81, since we're in meters per second, which is going to equal 4.905 meters per second squared. Okay. Now here, since we're trying to find the amplitude and the max velocity, we need to work with a special set of equations. So in vibrations, the fundamental vibration is some kind of a sine wave or cosine wave in this case. So cosine of omega t, where this is the radial velocity and this is the amplitude, and so on and so forth. So then x dot is going to equal negative a omega sine of omega t. And then x double dot is going to equal negative a omega squared sine of omega t. Okay, so if we're looking at acceleration, and actually both of these are absolute values, basically. Because since it's a sine wave, hopefully it's symmetrical along the zero axis, or whichever axis is its zero axis. So you put up these absolute value signs. So for acceleration, this max acceleration, at max acceleration, sine is equal to 1. Because if you look at a sine graph, it goes up and back down, only going between 1 and negative 1. So the 1 and negative 1 is partially why we have the absolute values. And then we know that sine of omega t is also going to equal 1, which will leave us with this equaling just a omega squared. And you can put absolute values up there if you want to, but it doesn't really matter. We just want it positive. Okay, so that means that the amplitude, the amplitude is going to equal 4.905 divided by 94.248 squared. So what I just did right there was I solved for a, and we have omega squared right here, which is 94.25 squared, divided by the amplitude, or divided by the velocity. Acceleration. I'm sorry, I went through a bunch of words. The acceleration divided by omega squared. And if you solve that out, you'll get a nice small number, 0.0005522 meters. And that is your value for A. So box that up. All right, so now x max, the max velocity. Well, again, if you're looking at this equation, sine is going to be maximum when it is equal to 1. So you can basically cancel that out, equal to 1, and x max is equal to the absolute value of a omega. And well, we have a and we have omega, so this is simply equal to 0.0005522 meters times the amplitude, which is, times omega, 94.248 radians per second. And going from there, this will equal x dot max velocity is equal to 0.05204 meters per second. There. So we just solved for the maximum velocity and basically the maximum amplitude. There's only one amplitude. In sine waves, there's only a single amplitude. So the amplitude and the max velocity using basically these fundamental equations of vibratory motion. Alrighty, so that's kind of an outline of a basic vibrations problem.